Hello everyone and welcome to the Math Blender. I'm Adnan Zedi and today I will start off with the topic circular measure and its dynamics in radian. So let's start. Okay, so before starting off with the topic we need to have prior knowledge, which is cosine rule, sine rule, area of the triangle, and all of these topics I have my videos already posted. You may want to look at them before coming here. So circular measure, we need to understand that the SI unit of angle measurement is not degree, although we are used to of doing it in degrees since our early childhood, but it is in radian. This is the SI unit to measure angles, and in such a manner that the conversion between degrees and radian, the rate of conversion is such that 180 degrees represent pi radian, or pi you already are aware of that pi is 3.142. I can convert any ratio in that. So for example, if I want to convert 60 degrees in terms of radian, so how will I do that? So we'll take the ratio method and I can say that 180x is equals to 60 pi, and x is equals to 60 pi over 180, and as I know that this is going to be pi over 3 radian. Now the angle that was initially in degrees is now converted to radian and has the same value as pi over 3. Now before starting off with this topic, and even in the examinations or while solving the questions, you need to be mindful that the calculator must be converted in radian mode. And how to do that? So the calculator version that I'm using is FX991EX, and press shift, press mode. Now you can see the angle unit, press 2, and then converting it, press 2 again to radian, and as you could see that there is a small r on the top of the screen which shows that the calculator is now in radian mode and I'm safe to do my calculations. If you press mode directly in other calculators, you will automatically see options like DEG, RAD, GRA. So RAD means radian, you automatically can press the button, so it's not as complicated as this one. So let's see how more things are. So a circular dynamics, let's say if this is my circle and at this point this is the center, so at any point we can see that. So let's say this angle here is x, and this is point A, this is point B, and this thing is called a sector that does not fall in a quadrant which is of 90 degree, that does not fall under semicircle which is 180 degree, or a full circle which is 360 degrees. So in order to formulate it, how to find out the area of a sector or the arc length is the length of this piece AB. Although this is the minor arc and this, the other one, is the major arc, the bigger one. So this one is the major arc, AB. Both are named as arc AB, but just that if we if we say major or minor, that's how we. So this angle here is, as we already know, that the whole rotation is either 360 degrees in degrees, or since 180 represents pi, then 2 pi radians. The same way 180 is pi, the same way you can say 90 is pi over 4, and you can write down any rest of the ratios by using the ratio method. That's all it is applied. So if you have to find out the arc length, so let's say if we already know that the length or the circumference and angle, so if the angle is 2 pi radian or 360 degrees, because I'm not finding out the formula for the angles in degrees, I'm now using in radian, so I will talk in these terms only. So the length is 2 pi r for a full circle, the whole circumference, when the angle is 2 pi radian. And if the angle is now x, what is going to be length? Let's call it s. We don't know what that is. We need to find this out. So if I cross multiply this, I can say that s is equals to 2 pi or x over 2 pi, and 2 pi cancels out, which gives you s is equals to r x. A lot of people write it like this as well, s is equals to r theta. It's as same. A lot of students do get confused when they see these heart symbols, so you may take it as you want it, as long as you are doing mathematically correct. So let's see a question which implies that. Okay, so now the length of the arc AB, I need to find out, this is a sector, small sector, and this is the length of the arc AB. I need to find this out. So I can see that radius is 10 and this angle is 2.3, which is theta or x. So for part A, s is equals to r theta, and s is equals to r is 10 times theta is 2.3, and I can say that the length of that arc AB is going to be 23. The length of the chord AB. Now if I look at the chord is this, the line that starts from A, ends at the other end B, and does not pass through the center. That's why it is called a chord. So for B, I can see that it's a triangle, which is not a right angle triangle, and I need to find out length AB, rest of the two sides, and an included angle is given. So it's the case of cosine rule, and I'll apply straight away cosine rule to find that out. So AB squared is going to be 10 squared plus 10 squared minus 2 times 10 times 10 cos of theta, which is 2.3 angle facing the sector. And AB squared is going to be, I'll just apply straight away in calculator, 10 squared plus 10 squared minus 2 times 100 cos 2.3. So I get AB squared as 333.26, and if I root it, the answer is going to be 18.3, rounding it off to one decimal place. Or in radian, angle measurement by default needs to be in 3 significant figures, or the answers has to be. The perimeter of the shaded region. The perimeter of the shaded region is everything that touches that shaded region is the perimeter. So as I can see that the green arc is also touching, as well as the blue line, that is the chord AB. So I'll write a statement. The perimeter is going to be length of arc AB and plus length of chord AB. So which is equals to 18.3, that is the length of the chord, plus 23, that is the length of arc. So 18.3 plus 23, so gives you 41.3. Now this is how we use the length, or s equals to r theta. So now looking at another new concept, So in the same sector that we had drawn previously, so if I have to find out the area of that sector, so this is the area covered by the sector. In order to find the area of a sector, we know that when the angle is complete rotation 2 pi, the area of the sector or the whole circle is pi r square, because when the angle is complete rotation, the whole circle comes into play. And if the angle is theta radians, we need to find the area for that. So in order to formulate it, let's apply the ratio method. Area times 2 pi is equals to theta pi r square, and area is going to be theta pi r square over 2 pi, cancels pi out, or area is equals to 1 over 2 r square theta. That's just one way to look at it. There's another way. If you see that 1 over 2, I can write this as r square can be r times theta, and r times theta is also equals to s, the arc length. So area can also be written as 1 over 2 r, and replacing r theta with s. Both of them can be applied depending on the situation. Now, let's look at area-based question here. This is just a basic question. If ABCD is a rectangle with AB 9, and so I'll just mark these. So AB is 9 and BC is 18. So this whole length is 18 centimeters, and O is the midpoint. Now, I need to find out, this whole thing is a sector OAED. When they say OAED, this means this, then the whole arc, and this. This is the whole sector. So find AO. So in order to find this length, AO, I already know that this is the midpoint, and this whole length was 18 BC, so this is going to be 9. And applying Pythagoras, so for A, apply Pythagoras, I'll get 9 square plus 9 squared is equals to AO squared. So 81 plus 81 is equals to AO squared, and I straight away use calculator for it. 9 under root 2. So the value of AO after taking the root is 9 under root 2. This is called the exact value. At times the questionnaire asks that write down the exact value, which means this is the exact value. If you are to round it off or write down the other value, this is going to be 12.73 or 12.7. Now, angle AOD. So tracing angle AOD is this angle. So this angle here. Now, as I can see that there are many ways in order to solve. So for example, this one is 9 under root 2, this length, and the other side, that is also the same, because this length is also 9 and this length is also 9. So we already are aware that both the triangles ODC and OAB are same. So one way of looking at it is that this since this side here is 9 under root 2, and since BC, since it's a rectangle, and BC was 18, so AD is going to be 18 as well. It's a case of cosine rule. So for part B, I'll apply cosine rule straight away. 18 squared is equals to 9 root 2 squared plus 9 root 2 squared minus 2 times 9 root 2 times 9 root 2 cos of theta, which I don't know. This is the angle theta. So I'll straight away use calculator. 18 squared is going to be 324 is equals to, so 9 root 2 squared is 162 minus plus 162 here minus 2 times, so they both are also multiplying as same as the square cos theta. So if I subtract 324 minus 162 is equals to minus 2 times 162 cos theta, this gives you 0, and eventually the whole thing becomes 0, and cos inverse of 0 is pi over 2. So the angle here is pi over 2, which is in degrees is as 90 degrees. So the area of the shaded region, it's actually this much area that was shaded. So area of shaded region is area of sector minus the area of triangle. So area of sector is 1 over 2 r square theta, and as you could see this value was 9 under root 2, which becomes a sector's radius, 9 root 2 square, and theta turned out to be pi over 2 minus 1 over 2 side, this is a right angle triangle because this turned out to be pi over 2. You can take straight away half into base into height times 9 root 2 times 9 root 2. This is going to be 162 times pi over 4 is equals to 162 over 2, and minus, this is the subtraction, so minus 162 over 2, which gives you a final answer of 46.2. So in this session we talked about the area and the arc length of a sector. In our next section we'll discuss more questions related to the past paper questions that are there, and we'll see how we can approach them. Until then, take care. Bye.